Today's lesson is about standard form. This is our third form of linear equations. The previous two you've learned already. The first one was slope-intercept form. The second one was point-slope form. And the third one is going to be standard form. So as you take your next quiz on this, I want you to pay close attention to what the directions are asking you to write it in. Sometimes they'll just say write the equation and you can use any form. Other times they'll actually say specifically which of these three they want you to use. So make sure that you read those directions carefully. So our standard form is a little bit more confusing than the other two that we've done. It is in the form ax plus by equals c. The reason that it's so confusing for many people is that we don't actually have a specific value that a, b, or c represents. Whereas in the previous forms we had m as slope, we had b as the y-intercept. So in this case, a, b, and c are not really going to represent any particular number that you need in your problem. The main thing I want you to remember, so I recommend actually don't memorize the form. What I want you to remember is that you have to get your variables and their coefficients on one side of the equal sign. And you're going to get your constants, which are your numbers, on the other. So we're going to go straight into some examples, which will hopefully clarify this idea. Okay, I would like you to, for all of these examples, write the equation in standard form. So my first example, I'm going to actually give you an equation. Usually I will not give you that. But in this case, I am going to ask you to write this in standard form. So if you look up at the formula, our standard form had something with an x first, something with a y second, and are equal to a constant, equal to a number. So all we're going to do here is we're going to move it over so that we move the 2x over, so that we end up getting negative 2x plus 3y. Notice how I changed the order of the x and the y, but I still kept their signs. The 3y was positive, I kept it as plus. The 2x was being subtracted, so I kept it as minus. Equals 8. And that's actually the only thing I need for my answer. That's all I need to do for each of these problems. So here's another one. I would like you to try this on your own. See if you can write this in standard form. So go ahead and pause. Okay, so we're going to end up getting y minus 5 equals 3x plus 6. You use the distributive property. Then what you want now is you want to make sure that on your right-hand side, you only have constants. You have no variables. So I'm going to move over the 5 by adding it to both sides. I also need to move over my 3x, so I'm going to subtract that from both sides. I will end up getting negative 3x plus y equals 11. And that's my answer. Our next type of example are going to get a little bit harder. So we're going to still write the equation in standard form. This time, though, I'm not giving you an equation. I actually am giving you only two things. I'm telling you that it passes through negative 1, 4, and I'm telling you that it has a slope of 5. So for all of this type of problem, the first step is going to be to start by writing the equation in one of the forms that you know. So you either are going to write this in slope-intercept form or in point-slope form. So because I have a point and a slope, I like to use the point-slope form in this case. So I'm going to go ahead and substitute in that point and slope. I get y minus 4 equals 5 times x plus 1. So that's our first step. Now, the second step that you need to do is you're not done yet because we want it in standard form. So you're going to now change it to standard form. And you do that by getting the variables on one side and the constants on the other. So remember, the constant is the number that's by itself. So I'm going to start on this one by using the distributed property. I get y minus 4 equals 5x plus 5. So now I'm going to keep the y where it is and move over the 4 by adding 4 to both sides. That gives me y equals 5x plus 9. I have to move over that 5x by subtracting that from both sides. I'm going to rewrite the problem now as negative 5x. My y is positive, so I keep it as plus y equals 9. For this next example, I would like you to press pause and then try this problem on your own. So our first step for this one is going to be to put it into either point-slope form or slope-intercept form. Point-slope, I'm going to use and get y minus 5 equals negative 3 times x plus 2. That gives me y minus 5 equals negative 3x minus 6. I'm then going to move over my 5 by adding it to both sides. Then I end up moving over my 3x by also adding it to both sides. I get 3x plus y equals negative 1. And that's my answer for that. So now, just for this one, I'll show you how you can do it if you really, really like slope-intercept form. So this is going to be our alternative method. So if point-slope is not your best thing, I would recommend that you use this if you're better at slope-intercept. So for my alternative method, I know what my slope is. I don't have my intercept, however. However, I can find my intercept. So what I'm going to do, if I want, I can put in my slope now. I am going to actually also put in that point for the x and the y. I get 5 equals negative 3x, and x is negative 2, so negative 3 times 2, plus b. That gives me 5 equals 6 plus b. If I subtract 6 from both sides, I get negative 1 equals b, or b equals negative 1. So now, unfortunately, I'm not done. I need to go back to my original y equals mx plus b, my original slope-intercept equation, and plug in those numbers. So once I get that, then I'm going to move over the 3x to the other side. I end up getting the same thing, 3x plus y equals negative 1. So I personally prefer the first method. If you look at the amount of work I did for both of those, the first method went a lot faster. However, if you are a little bit weak at point-slope form and you would prefer to use slope-intercept, that's fine with me. Okay, our last type of problem is going to be a little harder. Not impossibly hard, but just a little bit harder. So I'm going to ask you to find the standard form of a line that passes through 2 points. So if you remember from our previous section on writing things in point-slope form, you have to start by finding the slope of the line. And I'm hoping you remember this formula by now. But if you don't, here it is. So I'm going to go ahead and substitute in my values. I'm going to make this x1 and y1. I'm going to make this x2 and y2. I will get negative 2 minus 1 over 2 minus 1. That gives me negative 3 over 1. So my slope is negative 3. So now, if you use point-slope form, which I do recommend on this one, you can write this with either point. And actually, if you look at the 2 points we have, 1, 1, and 2, negative 2, I always go for the point that's the easiest, which is the 1, 1 in this case, I would say. I always choose the points that have no negatives or smaller numbers. So I'm going to go ahead now, write the point-slope form using the point 1, 1 and the slope negative 3. So once I do that, I'm going to solve this out using the distributive property. And I'm going to move over my 1. I also need to move over my negative 3x. Oops, I made a mistake. By adding 3x to both sides. And my final answer is 3x plus y equals 4.